modeling basics involve creating digital, three-dimensional objects using software by manipulating points called vertices, lines called edges, and surfaces called faces to build a mesh. The process starts with primitive shapes like cubes and spheres, which are then refined and detailed using tools to add complexity and realism. Once the model is created, it undergoes texturing, applying color and patterns, lighting, adding depth, and rendering, generating a final image or animation. The modeling process. Take 1. Planning and conceptualization. Before opening software, sketch out your idea and define the model's purpose. Do 2. Creating primitives. Start with basic geometric shapes, such as cubes, spheres, or cylinders as a foundation. Theme 3. Refining shapes. Use tools like extrude, bevel, and smooth to sculpt and modify these shapes into more complex forms. Chart 4. Adding detail. 5. 6. Incorporate intricate features and refine the model's overall accuracy and surface quality. Key components or vertices. The fundamental building blocks. Points in the 3D space that define the shape. Or edges. Lines connecting to vertices, forming the structure of the model. Or faces. Surfaces formed by multiple edges, which create the mesh that defines the object surface. The workflow. Modeling. The core process of creating the 3D object by manipulating its vertices, edges, and faces. Or texturing or materials. Applying colors, patterns, and surface properties to make the model look realistic. Or lighting. Adding light sources to the scene to create shadows and highlights, adding depth and mood. Rendering. The final step where the 3D model and its associated data are converted into a 2D image or animation. Design principles. Or form. Big, clear shapes that define what the model is and what it does. A proportion. Ensuring that the relative sizes of different parts of the model are correct. A detail. Adding smaller features to enhance realism. 3D modeling is the process of creating a mathematical representation of a three-dimensional object using specialized software. These models are used in various industries such as video games, film, architecture, engineering, and product design. Below is a comprehensive overview of the core principles and techniques of 3D modeling. Principles of 3D modeling: a geometry and topology, vertices, edges, and faces. Basic components of 3D models. Vertices are points in space. Edges connect to vertices, and faces are flat surfaces enclosed by edges. Polygons. Most 3D models are constructed using polygons, typically triangles or quads. Topology refers to the layout of vertices, edges, and faces. Good topology ensures better animation, rendering, and deformation. B. Coordinate systems. 3D models exist in a coordinate space, typically defined by X, horizontal, Y, vertical, and Z, depth, axis. Understanding local versus world coordinate systems is crucial for accurate transformations. C. Scale and proportion. Maintaining real-world scale and proportion is critical, especially for models used in architectural or engineering contexts. These surface normals. Normals determine how light interacts with a surface. Properly aligned normals are essential for realistic lighting and shading. Techniques of 3D modeling. One-box modeling. Start with a simple cube and gradually add detail by subdividing and extruding. Common in character and organic modeling. Two-edge modeling. Build a model by placing and connecting edges manually. Offers more control. Often used for faces and precise shapes. 3. Sculpting. Similar to digital clay. allows artists to push, pull, smooth, and detail surfaces. Excellent for organic shapes and high detail models. Tools: ZBrush, Blender Sculpt Mode. 4 NURBS Modeling. Uses curves and surfaces instead of polygons. Ideal for smooth and mathematically precise surfaces, e.g., in automotive or industrial design. 5 Procedural Modeling. Uses algorithms or parameters to generate models. Great for creating landscapes, patterns, and repeated structures. Retopology. Rebuilding high-resolution sculpted models into locally animation-friendly versions. Ensures clean topology and optimized performance. Tools and software. Popular 3D modeling software includes Blender Free, open source. Versatile for modeling, sculpting, and animation. Autodesk Maya, industry standard for film and game design. Autodesk 3ds Max, widely used in architecture and product visualization. ZBrush, best for sculpting and high-detail organic modeling. Best practices. Start with a clear reference or concept art. Keep polygon count optimized for the target platform. Regularly save versions and backups. Use layers and naming conventions for organization. Practice good topology for clean, deformable models.
Please share and like this video if you like it. Don't forget to subscribe the channel for more videos.